Welcome to a new video in my home automation series, and today I want to do a review video of this Groove beginner kit from Seed Studio. And this is not the first time I've received emails whether I want to review a development board, and I turned them down because I don't want to use a development board. I think I've probably gone beyond the development board. But probably by now, I think that my son is old enough that he might be interested in using this. And when I received this and I had a quick look, I thought that this is going to be a good one to start with. Mainly because the way this whole development board is created and thought about. Because as you can see, this is based on an Arduino, and this is like the central unit which has the Arduino microcontroller on it, or the Atmega. And it has the Arduino Uno layout, and then you have all these different modules that are also in the PCB, but they are laid in a way that they are pre-connected with the main board. But if you really want to, you can choose to break these out, just break these connections, and then you can just use them separately as well. And there are a couple of these Molex connectors provided. So if you want this, you can use it as it is. But then if you want to build a real project where you need, for example, one of these sensors to be in a slightly different location, or just want to, pack it in a slightly different way, then you can just break out the various boards and you can, rewire them. And this is what I really liked about it, because to be honest, I think, well, this is how I started in Arduino development. Is I was more comfortable using software than hardware. So when I started, I also wanted to start with something where I don't have to worry about the hardware. So it's like a unit which I don't even need to wire, just plug in the USB and program it, and then it's going to work. And I think it has all the different bits and pieces that you would want it. It is more geared towards sensors and environment stuff than as in like input and output devices, which I think maybe it would be better if it would have a little bit more. But this is how they designed this whole development board. And Seed Studio has a whole loads of additional components in this lineup. So as you can see here now, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, let's say peripherals. But I think in the whole lineup they have about like 32. So you can buy some additional lights and input devices, and they would all use these 5-pin Molex connector, so you can just wire them up to these connections. So of course you have to be aware of which connection this is, but for each of them there is a documentation, or how you want to connect them or how you can connect them. And since I was talking about development board, I just wanted to show you the one that I started with. So this one. So I started with PIC, and this was the QL200 development board that I started with. And as I said, it is really, really similar, because you have one single main board and also you have one single board here. Of course, this is designed to be not break out all, so it's like one board. It's the size of like a PC motherboard, but it had like keyboards and displays and a lot of LEDs that I can use, and real-time clock and SD card connection, and I think there are some analog devices here, and also you can use the pins if you want to, just like here you have all the pins if you want to connect it to like any Arduino Uno hat. And there was also a place here for an LCD display, but here we have an OLED display. So I think it is very similar. It's sort of the same spirit, and because I really like this one, I think this is going to be a good board to start with. And one of the reasons I wanted to use this, which it's not specific to this hardware, but it is integrated with a development tool which is very much similar to the Scratch language. So the Scratch language is a block visual language where you can just drag and drop commands, and you can just build a program that way. So, and my son was learning Scratch a couple of years ago, and he sort of liked it, but he wasn't too enthusiastic about it. So this is why we didn't continue. We thought they maybe are just too young for programming. So I think, that's going to be a nice connection with something that he has seen already, but now implementing the same sort of programming principle or way of programming now on a physical hardware. Before we go ahead and show you the kit in detail, I also wanted to show you this listing. So this is how, well, this is where you can order this kit from. And I mean, I don't think it's really expensive. I mean, you can definitely find, more expensive products. And it also contains all these sensors. And as I said, if you want to, you can buy additional sensors. So yeah, it is an Arduino Uno compatible. So it uses this Atmega chip, and then it has 10 of these modules. But there is a whole list of, well, there is like 300 different modules that you can also purchase with it. So, we will check what's this is loaded. And of course, there is like a PDF document that you can follow along, which contains some tutorials. And you can just read about the product here, and then the different things that I'm going to talk about on the screen anyway. So I'm not going to spend time here. You can see all the different modules and what you get. And actually, there is a documentation section here. So there are documents on the data sheet and some of the technical resources. But then if you really want to learn, you have all these videos here. So you have a couple of video courses on, some of them are on Udemy, and also PDF documents, and how you program it in just using Arduino IDE. But what I want is this Codecraft, or this is what I was interested in, this Codecraft programming language. And you have a whole documentation here, how you set it up and how you use, and also it contains documentation as well. And as you can see, there is one in English and there is one in Spanish as well. And there are some further documents and some things that you can watch or read related to this product. So now I'm going to show you the unboxing, and actually I'm creating this recording before I even do anything. So this is the first time I'm seeing this unit. So it was packaged in, or it was delivered in this package, and within everything is wrapped in bubble tape. And once I remove the bubble tape, this is how the entire kit looks like. So you can see the the main specs, that it's an Arduino Uno compatible, and then within this kit you are getting 10 different pieces in this PCB with the tutorials, and you see the various modules also listed here, and you can see also a link to the application. So this is how it all looks like. And after breaking the seal in 3 different places, I was able to get into the box itself. And I mean, nowadays I don't think you need a lot of documentation for things. I mean, it shows you the basics here, but you pretty much get the module, and then of course everything is going to be online. So let me unpack this from this package, if I manage to figure out how this opens. Yeah, you can open these sides, and you have a bunch of cables. So these are the cables that would connect these modules in the middle. But my understanding is that you have the bridge connection. So if you just want to use these modules and nothing else, you don't even have to use these. But of course, you can break out these modules, and then you need to connect them physically to one of the outputs. Oh, there is a micro USB to normal USB cable here. It's like the flat type, and this is probably like a short wire, which is good, because I think in most cases it's going to be connected close to your laptop. So yeah, you don't need a really long cable. And you just have to bend these tabs away, and then the whole PCB just comes off. So let me just put this to side. So this is how the PCB looks like. So you have the main board here with the processor and all these connections and the usual Arduino layout, and then you have the various modules here. And this is how the other side looks like. And you have some, and you have some of the things written on this side as well. It's hard to put it that it doesn't get a reflection. Yeah, and then you can see the small traces. So these are the traces that connect each of the modules with the, the main module, even if, even if they are connected to the main PCB. So if you're just using like this, you wouldn't need to use the provided connectors. And on further inspection, I just want to say about the this unit is that, as you can see on the main board where you have these 5-pin Molex connectors, so everything is labeled. So this is like the the D4 and the A6 and A2 and D3 and D7. So you know what which pins are connected. Or for example, you can see two I2C here. And for each of the modules, is it also shown here that this buzzer is internally connected to D5. So if you break out this board, you should connect this to the D5, which is where is it? Is it up here? And this one says this is I2C, this is D3, A6, A2. So it makes it easy to connect all the modules back to the to the respective pins here. And the air pressure and the OLED display are I2C, so you're getting two I2C connections. And then the rest goes to the actually the accelerometer is I2C as well. So you have three I2C. So they are going to the respective connection or the connectors on the board. So it makes it really easy to hook these up, even if you just want to move these units around. You don't want to keep them into this breakout board. And also, as I said previously, you're getting all these connectors here, which is the regular Arduino connectors, or the Uno connectors, so the Uno layout. And there is not much else on the other side. I mean, everything is labeled here, like which one is the signal, or SDA or SCL. You see the accelerometer, the directions or the axes. And you have a micro USB connector for the Uno, and there is a reset button as well. And I think I'm going to talk about these modules also when I go to the unboxing section of this video, which is going to come up next. But so in here, I'm just going to quickly go through it. So you're getting an LED module, which is just like a normal LED. You have a buzzer, so this is going to give you, it's like a piezo buzzer, so it's going to give you like simple sounds. So not wave, but like, beeps and that sort of stuff. You have an OLED display, so here you can, draw graphics. A very simple push button. You have a pot, so rotary potentiometer. You have a light sensor. You have a microphone, which is just basically like a sound level sensor. So this is like analog input. You have a DHT, temperature and humidity sensor. You have an air pressure sensor and a 3-axis accelerometer. And what I also like about this is that everything is nicely labeled here, so you can see that this module is connected to D4, this module is connected to D5, and this is I2C, and again D6 and A0. So once we start doing the programming, you can just look at the board and say, oh, okay, I want to control the LED, so I have to find the LED module in the Codecraft, and then of course you could use other port as well for LEDs, but this is connected to D4, so I need to select D4. And also here on the main board, as I said, you are just getting the headers for the normal Arduino, so you can use any hats or anything. But then you have these Molex connectors, and by the way, you are getting, I think, about 5 or 6 of these short Molex leads. So it's just basically 5-pin Molex connector. And so you can connect these modules either here if you break them out, because obviously you can see the traces. So once they are in the board, they are connected, so you don't need to wire anything. But if you, for example, if you have yet another I2C module, you can use one of the I2C outputs, or I don't know, maybe there is nothing, or actually this is connected to A6. I don't know if there are any inputs here which are not already connected or taken up by these modules as well. But again, like there is a UART here which is probably not used, but as I said, I2C, so you can buy an additional I2C sensor and connect them on top of the ones that are already here. As I said in this video, I want to focus on this Codecraft graphical programming language. And there is this English document, there is also a Spanish document here. And, it's not a short document, 144 pages. And it basically takes you through each of these modules, how you can use the various modules, how you build a program with it in this graphical programming language, which is actually something which is called a ThinkerGen. And this ThinkerGen works with other hardwares as well. So this Groove Beginner Kit is just one of them. But if you, for example, you have a BBC Micro, you can do the same. I mean, you can use the same programming language. But I think in the background, there is probably like some sort of Arduino compiler, which is doing all the compiling and uploading it to the device. And that's the other thing which I really like about this one, is I managed to find out that there is actually a separate project where you can use Codecraft to run code or on an Arduino, but that is just talking to the Arduino, and there is some generic sketch running on the Arduino itself. But here, it actually compiles an Arduino code from your graphical program and uploads it. So if I connect this development board to the, let's say, a USB power supply or a power bank, I can run the program which is running onto it. So it works just like an Arduino IDE. The code is getting compiled and it's getting uploaded to the device. So if I scroll further down, then we can see, oh yeah, you can see the various lessons, which are basically there is one lesson for each of the modules, and probably some projects as well. And yeah, it talks about the various modules. So I'm not going to spend a lot of time in it, because then we're going to spend the whole day here, and that's how the development environment looks like. And actually, there are two options to use the development environment. There is a web interface, which you can access from here, and this is what I'm going to use. Or you can actually have a PC client. So there is a downloadable client for Windows and Mac OS as well. And for some reason, when I use this link, the page opens, but when I select the Windows 64-bit option, I click on that and the download never happened. And I mean, I guess maybe there is something wrong with the link, so I'm pretty sure that will get resolved. So maybe by the time you are trying to download it, it's going to work. But I think the web interface is also good enough. So I'm going to show you how that one works. And yeah, so of course the first program is a blinky LED setup. So as you can see, yeah, it shows you, yeah, that's the module that we are talking about. And then, okay, what is an LED? It's going to explain. Okay, it's not even starting it's not even telling you what is the LED, but it talks about like light and the wavelength and, you know, how it is all made up, even though we have only a simple red LED. But okay, it's good that you understand the basics. And because this is going to be our first program, it also shows you how this environment looks like. So let me just actually use this. And as you can see, you can use a fair bit of different hardwares for this. So my BBC Micro, or the Microbit, sorry, BBC Micro was something else. So the Microbit is one, but I'm just going to use this. So as you can see, this Groove Beginner Kit is here, but well, of course it's an Arduino Uno, but I'm going to use this. And now I think it is time to connect this to my laptop. So I'm just going to take the USB cable and I'm going to connect it to it. And actually this is running some program now. So it does beep and it does a few things. So I'm just going to lay it out here. I think that's going to be good enough for us to see. And when you are using this for the first time, you have to download an application which is going to create the connection between this web IDE and the actual physical board. You can see this application here. It doesn't really do anything, but when you do it for the first time, you would have a button here which says, you know, download the driver. And it's just a simple Windows driver. You download it and then you install it and you don't have to do anything. But now because the driver is installed, I can connect to it. And I know that my Arduino is connected on COM10, so I have two COM ports, but the other one is my wireless mouse. So if I use COM10 and I connect, then it says it is successfully connected. And that's it. So now we can start programming. And of course you can create an account, you can log in and you can save your projects in the cloud. So I haven't done any of these, so now we are just going to use it as a new user without actually logging in. So which means that obviously whatever we do here is going to be lost if we turn off the computer. But as I said, the code will be uploaded to the beginner kit, so it will be there. And well, there is a code running on it at the moment, which you can probably tell that I did a program which generates sounds based on the light sensor intensity. But let's start with something simple, which is going to be a blinky LED. So you can see that in the Scratch interface, you have the various I think categories here, and then from that you select what you want, and then you just drag it here onto the main board. So you can see that, for example, under control we have the normal programming things like loops and repeat loops and until and if then else, repeat until, repeat while. And in serial port, yeah, we have stuff for serial connection. Output, we have, some digital outputs, operators that we can use in if. You can create your own variables, you can create your blocks, and then there is 3 different sections: groove digital, groove analog, and groove I2C. And that's how you can program, or sorry, use the actual peripherals. And as you can see, there are like absolutely tons of stuff in here, and more. And we have all these stuff because there are around like 300 different modules that you can buy. So as you can see, like water sensor, infrared sensor, magnetic sensor, ultrasonic sensors, and out of these we would only use a few because we have just a few. For example, we have the buzzer. And what else? We have a temperature sensor. So, and in I2C we have a 3-axis accelerometer, and we have the OLED screen, which is down here. But as you can see, there is RTCs and bigger OLED screens, and that's the DHT20 temperature and humidity sensor. So there's absolutely loads of stuff in here. Let's go back to the basics so you just have an idea how you start. We start with basically the start module. And of course it needs some explanation because it has a setup and a loop. But if you have ever programmed Arduino IDE, you know that this is the setup is the one-time code which executes in the beginning, and the loop is the loop section which then executes continuously. Oh, by the way, the other thing I wanted to say is that the Scratch language I was mentioning in the beginning, that is available like I don't know how many languages. For example, it is available in Hungarian, but this Thinkergen or this Codecraft is only available in these few languages. So again, if you are planning to use this for your child, then based on the languages that are available here, you might be limited in how much she could understand if she doesn't speak English or any of these languages. So this is set up. So we are going to do something very, very simple, and we are going to use the Groove Digital. And again, there is loads of stuff here, so I have to find the very simple LED and button pin, LED pin. Okay, so this is my LED, and as I said, it says the LED pin is D2, and if I go back here, sorry, you can see that it says the LED is D4. So if I go back to mine, then I have to set it to D4. And actually I want this to be in the loop section. So we are going to turn on the LED, and then in the control we have delay. Of course you have to remember this stuff. So I want half a second delay, and I can duplicate this to say that now I want to turn it off, and then another 500 millisecond delay. So it's going to be like a very simple flasher. And this is our first program. This is all you need to do. And I guess you can see all these like things like tabs, which basically tells you how you can connect things. And this is also quite nice because in control, for example, if you have a repeat, as you can see, it has like this rounded thing where you can enter something, and the variables are also rounded. So, it makes it visually easy to see how you can use the various controls. Or for example, if I do an if, it has a rhombus, or I think this is what it's called. And then if you go to operators, you can see the same object. So you can, as you can see, you can create these like something is bigger than 100. So this is how you create an if statement. And of course, anything you put in here is what gets executed within that statement. Okay, so now we are done with this, and we can just simply upload, and let's say it's COM10, and it's going to take some time. Well, this is why it is compiling the actual code, but it says that it's done. And this wasn't long, and as you can see, the LED is blinking. So it was just like that. It is really easy to use. And as I said, if I would connect to a power bank, the LED would still, blink. So this is the actual code which is running on the Arduino or the Atmel microcontroller. So it's not the computer talking to it, telling it to blink the LED. I think I'm going to use this sound example because my son likes audio, he learns how to play the guitar and the piano, so I think doing something which is audio related is going to be fun for him as well, or maybe something which is screen related. So maybe I can do this, that on the setup I show like an image on the LED screen, like this one. I mean, what you can do in the LED is fairly limited, because you can put an image and then you can just put text on certain parts of the screen. So you can't draw graphical objects, which could have been fun as well, but it's not possible. So I do that, and at some point I want to clear the screen as well. So since I was there, let me just bring that over, and let's also try that buzzer. And I think it is a digital, no, this was under analog, right? Yeah, it was the buzzer pin. And again, if I go back to if I look at the thing as well, so it says the buzzer is on D5. So buzzer is D5, and I want to play a E tone for half a beat, and then I add the delay, and then after I clear the screen. So whenever this program starts running, it shows this scary face or angry face, and then it plays a sound and it starts a delay. So that's good. Okay, and then maybe what we can do is we can also create some sort of loop. The loop is already here. So let's make a statement with an if statement. So let's say if, for example, if the light level is in between certain values, I want that light level to generate a sound, so like some sort of buzzer sound. So in the operators, I can, what I'm going to say is that if the light level is between 200 and 300, so I need two operators, and so I need two conditions with an AND. So I place that first, and I say that if something is greater, oops, I just need to play around. Okay, yeah, this is how I wanted it, and I can place it back. And if it's less than, and what I need is the light sensor, which is here. I'm not going to zoom in again, but it's on A6. So this is an analog input. So I think we have a light sensor here, so which is going to be on A6. So if it's bigger than 200, and I'm just going to duplicate this. And if it's smaller than 300, then I want to play a buzzer. So let me just duplicate it so I don't have to find. Actually, I only need this one, so I can just delete the screen and the delay, because the buzzer sound is a delay in itself already. So let's play D sorry, C3 and let's do a quarter beat. So upload. And what I noticed that based on what components you use, the upload can take more time or less time. And now because I added the OLED screen, I'm guessing it is putting in some of the OLED libraries such as I always forget what is the, well, there are various graphics libraries, but anyway, those graphics libraries usually are just bigger libraries. So, I mean, I'm talking here, but I think it's, well, it is already uploading because I can see the LEDs, but yeah, so it was like half a second, oh, sorry, half a minute probably to compile, so it wasn't that bad. And I'm not sure if it came through, but you can probably hear the buzzer, and there was something here on the screen as well. I think I can reset it with this button so you can see. Actually, let me just change to this full screen view. And I do this and I press the buzzer. Sorry, press the reset button. Yeah, we see the smiley face and the sound, and then after 1 second it's cleared, and yeah. I hope you can hear that. Maybe I'm just going to remove my mic. Yeah. And maybe what I can do quickly is I can just, duplicate this part. And if I put it behind the if, so if the values are between 200 and 300, it's going to be this sound. And if it's between 300 and 400, then it's going to play a different sound. And if we upload this one, now we can hear, okay, it looks like that it is resetting it twice. I don't know why it is doing that, but oh, okay, that's how it works. So now, yeah, now we can play around with the volumes. Well, sorry, let me just move my mic. Okay, so I think you get the idea. I think I was talking about this unit quite a lot, but I just wanted to give you the full picture and some of the, let's say, preconceptions that I had in my mind, how this would be useful for, not too much for me, but for my son, and how this development environment, I think it's really helping to learn coding. And by the way, when I say learn coding, once you have, you think you have gained enough proficiency using the Tinkercad, you can actually switch to the real code which is behind it. And as you can see, this is just a regular Arduino C code. So you have the the declaration of the SSD 1306 display. This is the binary code for the image, and then you have the buzzer tone. You have the whole setup function here, and then you just have a simple loop. You can see analog read, analog read. So just the way you would program a regular Arduino code, and you can always choose to just switch between these codes. And I mean, I guess if you start editing here, oh yeah, you cannot edit because this is read only. But if you want to do something which you can't really do in let's say in this Codecraft, you can do as much you can do here, and then just copy and paste this code over to an Arduino IDE and add some custom stuff to it, which for which you don't have a control here. But I think just to do some simple, well, I wouldn't even say simple stuff, but I think just to do some decent code and play around with the various sensors and the modules, I think this does really, really well. I haven't even touched the serial port, but of course you can just use the serial port, just like how would you use in a normal program, just to send debug information back to your console. And you can enable the serial monitor here, or if you want to send values over, you can use this plotter function, and then it just gets displayed in a plotter screen. So you can just plot values onto the screen, and you use this button to basically just open a serial plotter. So, and as I said, if you just want to use anything else than these modules, you just want to fall back to the digital or the analog pins, and you have access to all of these up here, you can just use the very basic digital pin and the analog pin here. So I think that would be my review of this Seed Studio Groove Beginner Kit and how it integrates with this, I think, really nice graphical programming interface. If you are interested in this product, I'm going to leave purchasing links in the video description, but I think that would be all for today. Thanks for watching, and hopefully see you in the next video.